Let's dive into the invisible, high-stakes balancing act that keeps a massive airplane steady thousands of feet in the air. You know, it's not as simple as it looks. It's actually a constant battle against the elements, and we're about to see exactly how a plane is designed to win. You know that feeling, right? You're cruising along, everything's smooth, and then there's this little dip, maybe a wobble. And just as you notice it, the plane seems to fix itself, almost like magic. So who's actually flying in that moment? Is the pilot making 1,000 tiny little corrections, or is the plane itself doing the heavy lifting? That's the big question we're going to tackle. All right, so the first thing we got to get our heads around is that stable flight isn't the default. It's not like driving a car on a perfectly smooth road. A plane is constantly being pushed, pulled, and tilted by forces we can't even see.
Just try to imagine the atmosphere as this huge, invisible, turbulent ocean. You've got sudden wind gusts, you've got pockets of air that are rising and falling, and all of it is just pushing and shoving the aircraft around. So a plane's journey is this nonstop battle, which means its stability has to be a really active, ongoing process.
So how on earth does a plane win this battle? Well, the secret isn't just a bunch of fancy technology, it's a fundamental principle that's deliberately designed into the very shape of the aircraft itself, and that principle is stability. So before we go any further, we need to talk about what the plane is always trying to get back to. It's a state called equilibrium. You can think of it as that perfect moment of calm, steady flight, where all the forces, lift, weight, thrust, drag, are in perfect balance. It's basically the plane's happy place, and its entire design is meant to make it want to return there. Okay, and this is where it gets really interesting. See, stability isn't just one thing. There are two kinds. First, you've got static stability. That's the plane's immediate instinct, the instant tendency to want to head back home after getting knocked off course. And then you have dynamic stability, which is all about how it gets back over time. Does it settle down smoothly, or does it kind of wobble its way back to calm? And honestly, this is the perfect way to think about it. A stable plane is like a ball sitting in a valley. You can nudge it, but it's always going to roll right back to the bottom. An unstable one, that's like a ball on a hilltop. The tiniest push sends it rolling farther and farther away. Commercial airliners are designed from the ground up to be that ball in the valley. They want to be stable.
And here is the golden rule, the one thing you really have to remember. You simply cannot have dynamic stability without static stability. It's impossible. A plane can't settle itself down over time if it doesn't have that built-in initial instinct to correct itself in the first place. One has to come before the other, period. But even with all this stability designed right in, getting knocked off course still causes the plane to move in pretty predictable ways. These are the inevitable wobbles you might actually feel as a passenger.
See, when a gust of wind hits the plane, it doesn't just flail about randomly. Its reaction is totally governed by physics, and it tends to move in two very distinct, very different ways. First up, you have pitching. That's the up and down movement, kind of like a very gentle roller coaster feeling where the plane's nose moves up or down. Then you have rolling and yawing. That's the side-to-side sway or wobble you might feel. Both of these are just the plane's natural reactions as it tries to find its way back to that calm, happy place of equilibrium. And of course, engineers have some pretty cool names for these wobbles. That slow up and down motion is called the phugoid mode. It's usually so long and gentle that pilots can correct it with no problem. But the one that gets a lot more attention is the Dutch roll. It's this combined rolling and yawing motion that can feel kind of like a corkscrew or like a skateboarder losing their balance. If that isn't damped out really fast, it can get pretty uncomfortable for everyone on board. So if these wobbles are basically inevitable, how are they managed so well that most of the time we barely even notice them? Well, this is where technology steps in, a kind of invisible co-pilot that is always on duty, 24/7. And here's a fascinating little paradox for you. Some really high-performance aircraft, especially military jets, are actually designed with less natural stability to make them more agile. But trying to fly them without help would be nearly impossible. So to make them safe and efficient, they need something called artificial stability. That artificial stability comes from something called a stability augmentation system, or SAS for short. You can think of it as a super fast, super precise system that senses those unwanted wobbles and makes tiny automatic adjustments to the wings and tail to damp them out, often before the pilot even feels a single thing. And it all works on this beautifully simple and elegant feedback loop that's running constantly. First, a sensor senses a tiny deviation. Let's say a wing dips down. The computer then calculates the error and instantly commands a control surface to move just the right amount. That movement corrects the plane's orientation, and boom, the loop is closed. This happens over and over and over, thousands of times during a single flight. Now, let's look at the ultimate test, the grand finale where all these principles of stability, control, and automation come together in perfect harmony, landing a plane on autopilot.
An auto-land sequence is just an incredible feat of engineering. The system locks onto radio signals that basically create an invisible highway in the sky, leading right to the runway. It then flies the plane perfectly down this path, constantly fighting wind and turbulence, while the autothrottle manages the speed with pinpoint precision. It's absolutely amazing to watch.
But the most critical, most delicate moment of the whole thing is the flare. Right before the wheels touch down, the system performs this incredibly graceful maneuver, pulling the nose up just slightly. This slows the plane's descent rate and bleeds off that final bit of speed, all to make sure the wheels kiss the runway as gently as possible. It really is the system's grand finale.
So the next time you're on a flight that feels perfectly smooth and calm, just remember the paradox at the heart of it all. That incredible feeling of safety isn't an accident. It's the result of an aircraft and its amazing systems actively, constantly, and brilliantly mastering the forces of instability to give you the safest, smoothest ride possible.